Alright, now let's take a look at an example of using that limit that we just talked about, okay? Of finding the instantaneous rate of change. Okay, so here, this question says, find the slope of the graph of f of x equals x squared at the point 39. So what that is saying, okay, is we want to take this curve and find the instantaneous rate of change at x equals 3. So this formula is what we're going to use. Now that this a value is the x that we're going to find. Okay, so what we first need to do, okay, before I can actually use this formula, is find these pieces of information that I need. Okay, so this is going to be the limit as h approaches 0 of f of 3 plus h. Okay, this a in the formula is the x value that I'm talking about in the question. So f of 3 plus h minus f of 3 all over h. Okay, that's what I want to evaluate for this function. Okay, so I need to figure out what each of these pieces are. Well, let's do that off to the side over here. I want to first evaluate f of 3 plus h. What that means is I want to plug 3 plus h in everywhere I see an x. Okay, so f of 3 plus h means I'm going to plug 3 plus h in here for x. Now in this case, I only have one x. But if I had, say, x squared plus 2x, something like that, I would have to plug 3 plus h in everywhere I saw an x. Okay, so let's go ahead and multiply this out. Okay, now remember, this is not the same as 9 plus h squared. This is a binomial squared, so I have to FOIL. Now, you may have talked about shortcut in a previous class. You may have heard square, square, squish, and double, or square the first, square the last, take 2 times the product of the 2. Any of those shortcuts work. Or, if you're not comfortable with either of those, you can just do 3 plus h times 3 plus h. Okay, same thing. But what we should come out with here is 9 plus 6h plus h squared, right? Okay, so that was this part. That was the f of 3 plus h. Now I also need to evaluate f of 3. Okay, so if I plug 3 into this, I just get 3 squared. That's just 9. So let's take this information that we found and plug it in here. Okay, so this will become the limit as h approaches 0 of, now my f of 3 plus h is right here, is 9 plus 6h plus h squared. So I'm just replacing this f of 3 plus h with 9 plus h squared. Okay? Now minus my f of 3, minus 9, all still over h. Now at this step, something should happen. Okay? We can see that I've got 9 minus 9. Right? Those will cancel out. Right? When we get to this step, something should always end up canceling out. Okay? So now what I have is the limit as h approaches 0 of 6h plus h squared over h. Now, in the top, you should notice that I can factor in h out of every term. So I can make this the limit as h approaches 0 of h times 6 plus h all over h. Now, I can cancel out these h's, and I'm just left with the limit as h approaches 0 of 6 plus h. Okay, and remember, our entire goal when solving a limit like this is to algebraically manipulate, and so we can get to a place where I can plug this value in. I am to that place now. If I plug 0 in for h, I just find that this value is 6. What we just found is that the slope of a line tangent to the curve at the point 39 is 6. Okay, so that's a pretty steep line. Right? We found that its slope is 6. Now, there is a second part to this, right? The second part says, and then write an equation for the tangent line at that point. Okay? And remember, we took a look at this, we reviewed this in the first section. Right? We said, well, to write the equation of a line, I need two pieces of information. I need the slope, and I need a point. If I have that much information, I can use point slope form. I have that information now. I know the point is 3, 9, and we just found the slope to be 6. Okay, so I'm going to use that information. Right? This is my x1, y1, and this is my m. So I'm just going to plug that information into my equation here. So y minus y1, y minus 9 equals 6 times x minus 3. Okay? That is the equation of my tangent line. And also remember, we talked about on the AP test, you can stop there. That is a perfectly acceptable answer. But we do want to be comfortable with putting it into slope-intercept form in case those are the only choices on a multiple choice question, something like that. So I would distribute the 6 through, y minus 9 equals 6x minus 18, add the 9 over, and we get y equals 6x minus 9. Okay, so what we just found is that the line tangent to the curve x squared at the point 3, 9 is y equals 6x minus 9. Okay? Now, visually, okay, let's take a look at what that means visually here. So let's get rid of all this. Visually, this is what we just found. Okay? Here is our curve, y equals x squared. We were talking about the point 3, 9. We just found that the instantaneous rate of change, the slope at that single point, was equal to 6. And then we found the equation of the entire tangent line. Okay? This is the line, y equals 6x minus 9. Okay? The y-intercept would be at 9 down here off of the picture. And then its slope is 6. Okay? That's what we just found, the instantaneous rate of change, the slope at a single point on a graph. Let's take a look at another example here. All right? Before we do that, though, let's make sure that we understand that all of these things on this list are the same thing. Okay? And we'll even talk about more notations for this here in a couple of sections. Okay? But the slope, okay, of some function at some x value, so like what we just found, the slope of x squared at x equals 3, the slope of the tangent line. Okay, so these are the same thing, saying the slope of the function or the slope of the tangent line. That's saying the same thing. Instantaneous rate of change also means the exact same thing. This limit that we just defined, right, to find this slope. Okay, and that quotient, that f of a plus h minus f of a over h, actually has a name. It's called the difference quotient. Okay? So all of these things mean the exact same thing. They mean slope at that single point, or instantaneous rate of change. Right? So let's take a look at another example here. Okay, let's say, given this function, x squared plus 2, we want to find the instantaneous rate of change at x equals -1, and then use that to find an equation of the tangent line. Okay, so start the exact same way. I want to first find the slope. Okay, let me use my other marker here. So our slope is the limit as h approaches 0 of f of, in this case, -1 plus h minus f of -1 all over h. Okay, so we need to evaluate f of -1 plus h and f of -1. So I'm going to do that off to the side here. So my f of -1 plus h, well, I'm just going to plug -1 plus h in everywhere I see an x. Okay, again, in this function, we only have one x. So this is going to be -1 plus h squared plus 2. Okay, so let's go ahead and multiply this all out and simplify. So negative 1 plus h, remember that's negative 1 plus h times negative 1 plus h. Okay, make sure you multiply that out. This is not 1 plus h squared. So if I do that, I will get 1 minus 2h plus h squared plus 2. And then I can go ahead and combine those and get 3 minus 2h plus h squared. Okay? So that was just this piece. That was the f of 1 plus h. Or I'm sorry, f of negative 1 plus h. So now, let's evaluate f of negative 1. F of negative 1, again, I'm just going to plug negative 1 in everywhere I see an x. So negative 1 squared plus 2. Negative 1 squared is 1, plus 2 gets me 3. So now I can plug these two pieces of information in right here. Okay, so f of negative 1 plus h. So this is the limit as h approaches 0. F of negative 1 plus h, we said it was 3 minus 2h plus h squared. So 3 minus 2h plus h squared minus f of negative 1. We said it was 3. All over h. Now again, just like our last example, 3 minus 3. Those cancel out. Okay? And I'm left with the limit as h approaches 0 of negative 2h plus h squared all over h. And again, just like our last example, I can factor an h out of everything in the numerator. So this becomes the limit as h approaches 0 of h times negative 2 plus h over h. I can cancel out a pair of h's, and I get the limit as h approaches 0 of negative 2 plus h. Now I am to a point where I can plug 0 in for h, and when I do that, I just get negative 2. Okay, so again, I have found the slope of the tangent line to this curve at x equals negative 1. Okay, this is my slope. So if my ultimate goal is to write the entire equation of the tangent line, okay, I've got my slope, and I've got my negative 1, but what's the y value? What's this entire point? Well, we already found that, actually. Right? We found that if I plug in negative 1, I get 3. Right? So the entire coordinate point here is negative 1, 3. So I have all of the information I need now to write the equation of my tangent line. I've got x1, y1, and m. So if I plug all that into y minus y1 equals m times x minus x1, we get y minus 3 equals negative 2 times x minus negative 1. So that just becomes x plus 1. And again, on the AP test, that's a perfectly acceptable final answer if you are asked to find the equation of a tangent line. But just for fun, in case we see something where our only multiple choice answers are in slope-intercept, let's go ahead and solve for y. So I'll get negative 2x minus 2, add the 3 over, and I get y equals negative 2x plus 1. Okay? This will be the equation of the tangent line, of the line that just raises my curve at negative 1, 3. Okay? So again, visually, let's take a look at what that looks like. Okay, so this is the curve, y equals x squared plus 2, and then this is the tangent line that we just found, y equals negative 2x plus 1. Okay, it just hits the curve at a single point. It is tangent to the curve. Okay.